Hi there, Paul Deed here again. Today we're going to have a look at the flat Earth as far as the model is concerned when it comes to the Sun and the Moon and the stars and their positions and whatnot. The first example I'm going to use is the Sun, and here we have what represents the flat Earth on its side, so we're looking directly across the flat Earth, say from the south, and here we have the Sun up here, and at this position here it is 12 noon, as you would imagine. The Sun is directly above. So if we were to go 3,000 miles towards the east, and this happens in reality, if you were to move or to ask somebody 3,000 miles towards the east where the Sun was when it was 12 noon where you are, the Sun would appear at a 45-degree angle. Now that's roughly, I mean it's not exact, the exact number's 3,000 and something. It's only very low, like it's like 3,100 and something, or something to that effect. But the Sun will appear at a 45-degree angle. So we can use simple geometry to work out how far on the flat Earth the Sun might be up in the air. If we travel 3,000 kilometres, or 3,000 miles, sorry, towards the east, and then we look up and the Sun's at a 45, that means that the Sun is at a 45, or if we look back from the Sun, if we could be on the Sun, it would be at a 45-degree angle compared to this position here. That means that this interval here, or this side of the triangle, because this is a square here, this corner is square, it's 90 degrees, so this side here and this side here are the same length. So we could guess that, or not guess, we can easily assume that the Sun from this position is 3,000 miles away. So bearing that in mind, if we were to go another 3,000 miles out to the 6,000 mile mark, the Sun now appears, and at the 6,000 mile mark, the Sun should actually be on the horizon. But in this instance, it isn't. It's at 30 degrees. So it's still well and truly above the horizon. And you can see the example there. This is pretty much to scale as far as the angles are concerned. So as you can see, 30 degrees. Then we go out to 9,000 miles, which should be in darkness. Yet you look and the Sun is still above the horizon. So it's not looking good for flat Earth at all. Okay, so now we're going to operate in the opposite direction here, and we're going to say that this isn't the Sun anymore, it's Polaris. Okay, it's the North Star. And directly below that, at this point, is the North Pole. And we look directly up from the North Pole and Polaris appears. Now we head south, or head out from the North Pole to a latitude of 45 degrees. And we look for Polaris, and it appears at a 45-degree angle. Okay, that's all good. Then we get to the equator, or the equatorial line, or the line that divides the south from the north, or whatever you want to call it on the flat Earth model. And we look for Polaris. And on the flat Earth model, Polaris will appear at 30 degrees. In reality, if you're on the equator and you look for Polaris, it's actually on the horizon. Okay, so there's a bit of a discrepancy there. So we continue to head south and we get to negative or 45 south latitude, and we look for Polaris. On the flat Earth model, according to this, Polaris will appear at 22.5 degrees from the horizon. In reality, Polaris is actually below the horizon and cannot be seen. So here's another major discrepancy with this flat Earth model. So it seems as though the flat Earth model doesn't work particularly well. And if somebody from the flat Earth community wants to explain to me what I am missing from that drawing to actually explain why or how the sun and moon and stars can possibly go down below the horizon when the Earth is flat, I would muchly appreciate it. Any comments, questions or answers to my question can be left in the comments section below. Have a great day. I'll see you later.